Good evening, everyone. The House of Sultan and Sons Private Limited and Method AI extend a very warm welcome to all the participants of today's Artificial Intelligence webinar. It feels nice to have you all here, and we thank you for that. A bit about the House of Sultan first. Pioneers in the field of book publishing in post-independence India, we cater to students from pre-primary to university level, churning out over 600 regular titles besides adding new ones to our stable year after year. Known for competently written, elegantly produced, and reasonably priced books, our publications are widely prescribed in reputed schools and colleges across the country, as well as in some neighboring nations. Our authors are distinguished academicians, professors, and educationists with vast experience and expertise. We are proud to be associated with them. I now introduce you the host of today's webinar, Dr. Sachin Gupta. Besides authoring artificial intelligence and data science textbooks for classes 9th and 10th, Dr. Gupta is Dean, Research and Innovation, Maharaja Aghasan Institute of Technology, Guru Gobind Singh Indraprastha University, Delhi. It's a matter of pride for us that Dr. Gupta's latest book on AI, Decoding Artificial Intelligence, has won the Outstanding Contribution to AI Literature Award. We congratulate him for this achievement. Besides, Dr. Gupta has also been HOD, Computer Science Engineering and MCA Department, Dronacharya Group of Institutions, Deputy Director and Head, Computer Science Department, Chandraprabhu Jain College of Higher Studies, affiliated to GSIPU, Delhi. With a teaching experience of over 22 years, which includes teaching undergraduate and postgraduate students and researchers, Dr. Gupta's academic pursuits have been fairly meritorious, winning him several awards, distinctions, scholarships, including the Certificate of Academic Excellence by GGSIP. Dr. Gupta has also contributed to various journals, conferences, and books for schools and higher education, both nationally and internationally. His achievements are truly commendable. I now request Dr. Gupta to take you through today's session. Thank you. Have a great day.
Thank you so much for that kind introduction, sir. We have had the opportunity to speak to several of practicing faculty members over the last week. With a workshop in Amity International School, we collected a lot of faculty members from junior and higher classes. And there was a whole lot of queries, so much fun. There was so much interaction with the people that we are overwhelmed. We appreciate you having invited us there. And in the process, some faculty members requested that can we have a session on mathematics in ML? And this was last week also. So we are conducting a background on how mathematics helps machine learning and artificial intelligence. There is a disclaimer needed here. I have seen mathematics from the perspective of both what we are ought to teach in our class 9th and 10th and 11th, 12th. And I have seen it from the perspective of higher education also. So there is a usual requirement that for a student, the mathematics is going to be very simple when you are teaching them in a classroom for class 9, 10th, 11th. For a faculty, you should have a basic understanding of a higher level mathematics that you should be able to understand what is happening. So I believe most of us are computer science teachers. We are not mathematics teachers by background. And mathematics isn't, we are not so fluent with. I am not very fluent with mathematics as compared to some other teachers who are teaching physical sciences or mathematics. But the requirement of the subject would be somewhat a little higher than what the students would require. So I am covering what machine learning algorithms and processes require in the mathematics part. aim to discuss it with the teachers who are teaching it. And then I'll discuss that what you are teaching in the classroom, how we have created resources for that so that you can take it to your classroom, make it easy for your student both ways. In the process, if you have any queries, any at all, some of which I may answer, some of which I may not answer if I am not exactly comfortable with the question immediately, but we'll certainly answer them, maybe on mail, maybe if I can't answer them today. So most queries, whatever you want to ask are welcome. Allow me to share my screen before we start. So this is what we are going to discuss today. I hope my screen is visible, everyone.
Yes, it is.
All right, sir. So we will be discussing machine learning mathematics. Then across our curriculum, which we have covered so far in class 9th and 10th and 11th, most of the topics go around probability and statistics. But as a computer science teacher teaching machine learning, all of you must be very well aware about these three basic tenets, that is including algebra, calculus, and probability. I'll include stats and probability into one topic together, taken together. If I were to speak of machine learning in the domain of higher education, the minimally required subjects for AI algorithms that my students are expected to work on is statistics and probability for data collection, sampling, reasoning, real analysis and complex analysis, then numerical computation and optimization for parameter optimization, calculus for parameter changes. There are some miscellaneous requirements, basics and geometry, operation research, discrete math, algebra family, information theory, and all of this is not required for us computer science practicing faculty. We just require three domains that we need to understand out of all of them by and large. Sometimes we may require to additionally understand some portion which is not uh, in that three domain, that is statistics, probability, and algebra. If something comes across, then we would cover that point there. So basically, artificial intelligence draws from the domain of it is the process of solving a problem. When we add learning to it, it is a process of learning also. That means when I'm adding my uh, programs to learn automatically from data, that branch of artificial intelligence diverges to machine learning. In the process, there is always the problem of that uncertainty is always there. Whenever I am making a prediction, I am not calculating. I am simply saying that this is the chance of what am I saying. It is I am 90% sure of it or 80% sure of it. It's always probabilistic. It's always uncertain. So whatever reasoning that my machine learning algorithms learn from data, that always have a degree of uncertainty to it. And that is the importance of probability in our area. We also have to work with representing knowledge, whatever we have acquired, reasoning and communicating that how are we performing with in this domain. So for all of these, mathematics is going to be absolutely essential. Right. The first part is this we are going to quickly cover and then move away from it. I hope all of you know that there are two types of learning, supervised and unsupervised. There is another, RNN also. Right. What do we do in unsupervised learning? Can anybody put it quickly on the chat window? What is the basic premise? What is the basic type of algorithm or what is the basic type of activity that we do in unsupervised learning? Anybody? Or I'll answer for you. Uh, no one? Okay. Labels are not provided, comes from YouTube. What we basically do there is clustering, that we would take in a lot of data and we would usually cluster them together into groups based on the characteristics of data. So once you see that clustering, what is happening, you would always notice that if I have to decide that how is a point similar to another point or how is a data value similar to another data value, we would need to find the distance between them. After representing them on the mathematical plane, we would need to find what is the distance between them. And there comes the requirement of geometry. In addition, we have to understand the concept of creating of a line whenever we are doing linear regression, creating of polynomials whenever we are doing logistic regression, creation of plane if our data is into more dimensions than 2. If it is 3D, then it would not be sufficient to draw a line. We might have to draw a plane. So there are a lot of different geometrical concepts that actually start machine learning with. Then wherever we are doing machine learning for the school level up to the class 11th and 12th, we would usually work with the three domains. There is linear and matrix algebra. I mean, most of the data that we are going to work with is going to be represented in the computer before we start working with that using matrices. I'll come to that again. Then we'll use calculus for neural network. Then we'll use probability theory for principles and application, and some other concepts also required for breaking down. So first, how do we use, or what is the purpose of using algebra in machine learning? Linear and matrix algebra studies vectors and matrices. For the time being, leave vectors aside. Let us simply talk about matrices only. So matrix is a concept that all of us know. It comes in early mathematics, that we can represent our data in the form of matrix, where you have rows and columns and you can place the value of each of the row and column in this. And matrices have been commonly used for calculating equations also. So linear algebra and matrix algebra, they study vectors. They are used to solve mathematical machine learning problems. And algebra is primarily responsible for this, that whatever type of data that we have, if there's the image is existing in pixels, we take the values from those pixels, we represent them as matrices. If I'm speaking, my audio is reaching to you in a digital form. This audio is also converted into a digital format represented as a matrix, and then we can process it as a signal. The features of data, like for housing prices, what is the number of rooms, what is the area of the house, what is the location of the house, all of that would be converted into a matrix before we process it. So algebra is important in artificial intelligence for AI requires problem solving, planning, learning from data, that is for ML, deep learning, or recurrent learning. Then knowledge and reasoning, computation, communication, and NLP. And all of that require algebra to store the data in mathematical objects before we start processing that. So the requirement of algebra is that we represent our data as possibly scalars. Scalars are simple single numerical value. And beyond that single numerical value, we can have multiple numerical values. We can take it down to a two-dimensional table. We can take it to a three-dimensional table, or towards tensors, where tensors allow you to represent multi-dimensional tables in the single space that you are working with. So tensors are the foundation of all deep learning algorithms that we are using in machine learning. If there are any questions, please do feel free. There are a lot of concepts which are typical here. The topic itself is typical, but I'm just trying to give you what foundations, if in case your students ask, sir, why do we require algebra for our teaching? So you can tell them that all representation of data in machine learning is basically based on linear algebra, where we represent data as scalar, vector, matrices, or tensor, whatever be the kind of data, whether it is features, whether it is numerical data, whether it is audio data, whether it is text data. So you create TF, IDF vectors in the NLP also. And if you are working with images or videos, then all the pixels are also converted into matrix data in tensors and then processed together. So that is the basic requirement of algebra in machine learning. Then vectors are used for storing your n dimensions. There are some vector product tools that when we process data, it applies a lot of operations on the matrices which were common to normal matrix operations in machine learning also. The second pillar of mathematics in machine learning is calculus. Calculus is used for optimizing machine learning algorithms. So whenever we want to understand derivatives, whenever we want to understand why is something changing the way it is changing. So for instance, if we are trying to predict the value of a stock price over a couple of years, then there is always going to be a constant change in the value. Sometimes it is going to grow, sometimes it's going to go less, sometimes it might grow very fast. So that prediction is something which is based on change. So calculus provides the tools for analyzing functions. It allows us to understand how or why is the change happening. And it allows us to create a model where we can check the performance of the model also. So one key concept in machine learning is gradient descent. This is something that we must have heard of, if not used so far. So gradient descent is that, I'll show you the diagram. Gradient descent works like I start with some value of a parameter for which I am trying to minimize the loss. And we keep on changing the value of those parameters, keep on decreasing the value of loss till the time we reach a particular point where the loss goes minimal. So all of the machine learning algorithms, they are trying to minimize the loss function, minimize the error function or the loss. So I want my algorithm to be as good as possible. How do I make it good? I have a actual value which is supposed to match. This is the value which I am calculating. I keep on reducing the gap between them by eliminating the error from my prediction and making it match the real value as far as possible. So this is usually done using calculus, where we are trying to minimize the error bit by bit using gradient descent function, or we are trying to make our model stabilize towards a value that is giving us the best possible answer. So that is the basic requirement of calculus. Besides, there are a lot of other requirements also that we do. Then this is something that you are familiar with, very familiar with. Can somebody open their mic and say what a model is? I hope you can. You are allowed to open your mic. Anybody from the participants? Uh, how do you define a model? This was a question that came up yesterday also. Renuka, Sarita, Shanmuga, Varsha, anybody who wants to just simply answer that what is a model in your understanding? One answer says algorithm. No. Algorithms and models are different, and I'll tell you why. This is a good starting point. Yes,
Trained
please.
and tested.
Yes. Prototype. Model is a prototype is a good synonym But in machine learning algorithms, models are a little bit differently defined. They model basic decision making. They can be very, very, very complex. Varsha. Okay, I am getting some feedback, and let me share two things with you. Okay, one is layout, learning. All right, what we work on in machine learning is that there are two parts to every problem that we work on. First part is, what do we learn from? We learn from a lot of data. So all of the inputs to my data go to the algorithm, the machine learning algorithm. We feed it my algorithm may be decision tree for that matter. So for the decision tree, it has to make a decision between whether it is going to rain tomorrow or whether it is not. We feed it a lot of historical data of the air sensor, pressure, temperature, uh, humidity, and all that we all feed to the algorithm. And at the same time, we also provide the output to the algorithm that based on this pressure, temperature, and humidity, it rained or it did not rain. So you provide the input output pairs to your algorithm, right? It extracts information from that, it learns, and then it creates the model. This model is a mathematical representation of the information that my algorithm has collected from the data. It has understood, it has extracted. So whatever mathematical relationships exist between, like, this much of the temperature plus this much of the humidity plus this much of the pressure equal to rain. That kind of mathematical relationship would be a model. All right. In this process, again, there is another thing that happens, that decision tree was my basic requirement, that I was my algorithm. Now, algorithms or flowcharts or programs, as you write, whenever you write a function, within that function, there is something that you call as parameters that you can pass. So function parameters may be sometimes default, if you know any programming language, that the default function parameters are always there. So my model is usually working with the default parameters. When I'm passing the data to my algorithm, it uses the default parameters. Later on, I want to say that my decision tree had only 10 levels of reasoning. Why can't I increase it to 15? So when I want to increase the parameters from or change the default parameters, then I use something called parameters and hyperparameters, which allow me to fine tune that my model was not working so good. So let us tweak. My decision tree had only 10 levels. Now let us take it from 10 to 15. When I'm increasing the default value from 10 to 15, I am fine tuning my model. I am giving my model more information to work with. I am allowing my model to learn more details. And that is where we try to work with parameters and hyperparameters. This works with the validation part. And our basic requirement eventually is we want to minimize or maximize cost function with respect to parameter. So we want to minimize the probability of error in our prediction, that we can say with 95% surety it is going to rain tomorrow. That is the kind of working that we work with within machine learning. So I hope that you understand that the algorithm is different. The algorithm is the one where we are feeding in data. The model is the one that we are creating. After creating the model, you feed in a different numerical value to check out what would be the output. That happens. So your model is something which is static. Your algorithm gets a lot of data from which it is learning, and after learning, the outcome of that learning process is a mathematical equation, maybe with some default parameters, maybe with some different parameters, and that together, that relationship, mathematical relationship, plus the parameters, plus the cost function, that all becomes a model. So I hope that part I have made clear. Any queries on this from the same? If there are, let me open my chat box again and see if, okay. I hope I have answered to the most that what is the distinction between a model and an algorithm and about decision making also. So the next part comes in what is the significance of probability in machine learning. So whatever uncertainty values are there, whatever is probabilistic, whatever is on the basis of chance, that part is always answered by probability. So my data may have randomness, my data may have variability. Wherever there is a variability that in some months there is rain happening, in some months rain does not happen. By chance, it might happen that sometimes we have rain in winter also. But what is the probability that there would be rain in winter? So usually there is no less than not even 10% chance of having rains in winter. So if I'm creating a model, this probability, this historical data that we have collected over the years that usually there are no rains in winter, that is something that is going to help my model learn or my algorithm learn better to create a better model. So statistics and probability together, statistics for collection of a lot of data and probability for adding uncertainty into that data, that variability component, both of them put together allow us, my machine learning algorithms to learn better, to take into consideration that there might be a possibility of something happening or not happening. So there are a lot of concepts between stats and probability. You use descriptive statistics to describe your data first, summarize whatever features are there. Some of the features might be redundant because they are parallel, they are same to each other. We might want to remove. So you see correlation happens, helps you to understand that these two features are exactly correlated. I can use one of them. Why do use both of them? If I can simply remove one of them, I would be able to still learn. Then probability theory allows us the analysis of random phenomena. And if there is a sequence of events happening, the chain rule allows the Bayes theorem, then distributions. Okay. Can somebody quickly tell me on the chat box that what is balanced data, what is unbalanced data? This is again something that is important for all of the teacher. What is balanced versus imbalanced data? Can somebody quickly put in the chat window or can speak out also? Yes, all of this is relevant for class 9th, all of it is relevant for class 10th, 11th, and 12th. And this is why I started out with this thing that as a student, they might have a lot of questions which we may not have answers to unless and until we understand what is the foundation level at which my machine learning algorithm is working. So there is one question coming, one answer. Balanced data has less NAN. NAN means not a number. Balanced is relevant to the model and sufficient information. Okay. What if I am trying to classify cats and dogs? When would I say balance? Perfect. That comes from Dishu. Dishu, perfect answer. A balanced data set is the one that contains an equal or almost equal number of samples from positive classes and negative classes. So if I'm trying to classify, let us say, between cats and dogs, I would be able to say that the number of images of cats and the number of images of dogs should be almost equivalent, right? There we would be counting the number of images. We understand that my data set is balanced. What about the values where we do not have images, whatever where we have only data values which are not countable? When we do not have data values which are not countable, in that case, we use something called distribution. We want to pick up data from distributions which are, or data according to distributions which are similar. So statistically, if I'm going to pick up values from two different data sets, but both of the data sets have similar distribution or they are shaped similarly, that allows us to understand our data sets better. So distributions and sampling and hypothesis testing, all of these concepts come from statistics. All right. So probability, chain rule, Bayes and distribution, they are applied in artificial intelligence, for reasoning in the Bayesian networks, for reasoning over time, for decision making in the decision network. They are also used in machine learning for classification algorithm, estimation or prediction of a value, or even in generative artificial intelligence. And in NLP, you use them for modeling language, parts of speech, speech recognition, and machine translation. These are the basic requirement of probability and statistics in different domains of AI, ML, NLP. Right? We use them in computer vision also for reducing the number of characteristics in an image. Then mathematics is the backbone of machine learning. I'll show you how. Whenever you are, whenever you want to create an algorithm, if it was not a simple sequence of steps, an algorithm would always require you to work with logic. If it has any mathematical calculation, you would require functions and relations to work with that. If there is a repetitive recursion possible, then recursion is a mathematical concept. How are you going to store the data? Where are you going to store the data? What data sets are being used? That would be stored in data structures. So you may want to understand reason graphs also. How much time is it taking? How fast is my algorithm working? How slow is the algorithm working? All of that comes from discrete mathematics. So any algorithm, any machine learning algorithm would always be a combination of all of these details coming from mathematics, right? So designing of a machine learning algorithm is always finding its fundamentals in mathematical concepts, which we have given here. I'll give you a small example of what we discussed, cats and dogs in ML. So in the initial stage, you need to decide the sample size. How many images should be sufficient? My data set should be large enough to provide meaningful results. I can't just have two images of cats and two images of dogs and then say this is generalized, that I would be able to now capture all the features and I would be able to say the next new data image is a cat or dog. I can't do that. And also I need to balance the data set with an equal number of dog and cat images to avoid biased results. There, mathematics is working to ensure my sample size is large. That comes from statistics, that what should be an ideal sample size. Then distribution, that I should have balanced data set with data coming from both the domains. The next part comes in data pre-processing. We convert raw data into some format that the machine learning can understand. So for cats and dog images, we may have to resize the image. Resizing the image is actually happening with a matrix operation that we call as scaling. So we store the entire data into a matrix. We scale it by a factor of half or 1/4, where because I can't just reduce the image by compressing it. Compression always loses data. So I save the data to a matrix. I resize that by a scaling operation that applies to it. We normalize the image. We put the pixels within a specific range, and sometimes our images are not sufficient. We have to rotate, we have to transform, we have to shift the images to different points of reference. So all of that is happening in the steps called augmentation, or we want to create more data using the same images that we have. And all of that is data pre-processing for this specific step. Any questions so far? None? Then the next step goes in feature extraction. So you extract meaningful information from data. How do you extract what information do you extract from images is something like you apply filters. You want to find out the edges of the images that are shown to you, because the most important part of an image is that what are the edges which are defining the shape of each individual component in an image. You also want to see the texture analysis, like whether the fur is soft or whether the fur is coarse or whether there is no fur present on the skin. So that is again that all of these image processing operations are working with the help of matrix operations that is presumable by algebra. You decide the model, you select your appropriate model, then ML uses linear algebra to reduce the dimensionality. That okay, these two particular columns in my data set are exactly same. I can choose only one. Then the height and the weight are proportional, let us suppose, in both the images. So I can choose only height or I can choose only weight because both of the features are not required. So some features or some dimensions we drop. Because machine learning always is a very computation intensive process. So if we want to take a lesser number of features to extract maximum information out of that, that is always useful. So all ML algorithms try to reduce the dimensionality. All of them try to reduce the total number of features that we are extracting our information from. And that is again work with the help of algebra. Calculus, as I said, is used for gradient descent, that we want to reduce the error of computation, and probability for finding that what is the chance that the image that I am seeing is a cat. Is it 90%? Is it less than 50%? If it is less than 50%, I would say it's a dog. If it is more than 50%, I would say it is a cat. So that is the probability theory that we use in this extensively for model selection and training. And finally, we want to evaluate the model. So my concepts are accuracy, precision, recall, F1 score. There are a lot of mathematical parameters that you use to evaluate that how good is the model that we are working on. All right. So that is the part of how mathematics is fundamental to any machine learning operation. I want to now show you what we have created for your class 9 experience. I hope all of you have access to this web resource that we have shared. This is for the upcoming book on machine learning. The part 3 deals with mathematics and statistics. For your students, you would be able to show them the reason why machine learning is using mathematics. So patterns are always a machine learning phenomena that every machine learning algorithm want to understand what is happening in a pattern. So mathematics appears everywhere in our general life also. So Fern, symmetry, Fibonacci sequences, they are appearing in the sunflowers. So patterns are not occurring only in mathematics, they are also occurring in data. So all arithmetic sequences are patterns, geometric sequences, square numbers, even numbers, parts of two. You can tell your student that patterns are the one things which allow you to go on, understand. That is understandable only by if you understand mathematics. Then AI always learns from patterns. So AI can analyze weather patterns to predict storms, identify objects in photographs, or recommend products. They are all a part of pattern recognition. You watch a lot of videos of Kishore Kumar. So that is a pattern which your pattern or recognition algorithm or a recommendation algorithm is going to learn from. So everything which AI or machine learning learns is usually from a pattern. There are some exercises which your students may do. Then machine learning uses applied to understanding data, probability and statistics, pattern recognition. Some of the tools which you can tell your student include that mean, median, or mode. That what is the average score of a student in the class, the mean. That statistical understanding of data is essential to machine learning. Calculus for derivatives, that how do data items change with respect to each other. If you mix colors, how are you getting the perfect shade of green? If you add more blue, how is it going to affect green? If you add more of yellow, how is it going to affect the shade of green? If you add more number of rooms to a house, how is it going to affect the housing prices? If you affect less garage space to a house, how is it going to affect the housing prices? All of this is calculus. Okay. Then the likelihood of different events is probability. We have added sections on statistics. Where did statistics come from? How historically statistics have been important. We have added examples from understanding statistics using cricket in your book. What is frequency? How do we work with tally? What are dot plots? What are different representations of data in the form of statistical data? That comes, and what basically statistics does. It looks at the what. What is the pattern in or the trend in data you have. It does not tell you why things happen, but it tells you what is actually happening in your collection. Right. So you can see statistics understands your data and summarizes it. That's all it does. And you can apply statistics to a lot of different applications like climate action, that what is the per capita emission of per country. You can relate it to weather forecasting, you can relate it to eradication of poverty, you can apply it to disaster management. That's all about statistics. You can show uh, different charts and tables. And we have included use cases in sports also, so that you can involve certain activities with your student. The second part of that is big use case where the students understand how they can collect data themselves and apply statistical models to understand what statistics does. And finally, we discuss probability. That probability in data science is talking about that likelihood, possibility, chance, prediction. All of these concepts are related to probability. So you would have to tell the student between what is a random guess, that my son may become pilot one day, is a random statement, and India has a high chance of beating Pakistan in the next Cricket World Cup, because historically, statistically, it has happened 8 out of 8 times previously that has happened. So it's an educated guess. Right? We can say it is very likely to rain today because the sky is overcast. This is an educated guess, because normally what happens whenever there is overcast sky, there is rain happening. And the teacher may give the tuition test this week is an intuition. It is something that we do not know for sure. It is something that we can only make a guess about. Right. So this part is probability. We have discussed the terminology of probability, what is an experiment, what is an outcome, what is sample space, understanding chance events. There are some very good other resources also from the web, which you would like to share with your students, which they can understand. And then non-technically, we make them understand the terminology of what is impossible to what is a sure event using certain use cases. This much part, along with descriptive versus inferential statistics, is usually enough for a student studying class 9. Right? But for a teacher, it is essential to understand how statistics and probability are essentially being used in machine learning. Right? So I hope you have access to this resource already. If not, you can request to join the AI teachers group that we share the information with, and we can take it forward from there. I'm just throwing open my chat window for any questions that you may have for the time being before we close the session. Okay. One question is where we can procure the book. Ashish sir is going to help you with that. You can send an email to ashish.agarwal@sultanjan.com. Any other question? Please feel free. The chat is open. There can be any question. No question is good or bad. I always want to see that if there is interaction, it always helps. Any doubt, any single doubt that you may have related to how is mathematics essential to ML? Any questions on YouTube, sir? Or otherwise, we can close the session for the day.
No questions on YouTube, sir.
Devjani ma'am, there is a complete series of all the topics related to class 9th and 10th on our YouTube channel. just join the chat group, send us a query. We can share the YouTube channel link also with you. All right, I hope that we have covered a lot of ground today. Ashish sir has shared the playlist with you. Debjani, you'd be able to access whatever sessions we have covered. Thank you so much for joining everyone for the day. Manmohan sir, we can close the session.
Okay, thank you, Dr. Gupta, for this interactive and highly informative session.
Okay, there
And
is a
of course,
question.
thank you all those who tuned in.
Vijayalakshmi, please join the group and we can answer the query there.
Sachin sir, if you can take this last question.
Okay. So you say how much training data is required for a successful AI model? That depends on a lot of factors. We start out with a sample set. We start out with a data set. We train our model. We evaluate our model. If my model performance is as per my expectation, I would not require more data. But if my model performance is very bad, then either I change the algorithm or I get more data. So I would never be able to answer that how much data is sufficient. But your model performance is the one which is allowing you to understand whether the data that I took was sufficient or not. All right. I hope that answers your question. Evaluation is required for understanding that how much data that was required or how much was sufficient or insufficient.
Thank
That's
you,
all.
everyone.
Thank you, everyone.